What is poppin', my lovely folks? And welcome back to another episode of Maths. Thanks for joining me today, and we are going to be continuing our fractions journey. In the last video, we saw how to convert from fractions to decimals, and we basically exploited a property of fractions where we saw that fractions were just division in disguise, and we used that in order to convert them to decimals. So now we're going to be doing the opposite. We're going to be converting from decimals into fractions. So before we do that, though, let's look at a pattern with powers of 10. So we'll title this section Multiplying and Dividing by Powers of 10. Alright, so what do I mean by powers of 10? Well, powers, that's exponents, right? So an exponent is taking a number and multiplying it by itself multiple times. So 10 squared, that's 10 times 10, or 100. 10 cubed, that's 10 times 10 times 10, because we're timesing 10 by itself 3 times. That's what the cube is telling us. So we get 1,000. 10 to the 4th, as you can maybe see by the pattern, it's just going to be 4 zeros now, right? We're doing 10 times 10 times 10 times 10. That's going to give us 10,000. And so on and so forth. Maybe let's do one more. 10 to the 5th. That's going to be 100,000. 10 to the 6th would be 1,000,000, and so on. And we also get 10 to the 1. That's just taking one copy of 10. That's just 10. So 10, 100, 1,000, 10,000, 100,000, 1,000,000. All these numbers are what are called powers of 10. And these are going to be very important for converting from decimals to fractions. So you might not see why that is immediately, but we're going to get there. So we'll start with multiplying by powers of 10. So if I take a number and I multiply it by a power of 10, essentially what I'm going to be doing is I'm going to be adding the amount of zeros we have. So for example, 3 times 10 is 30. So we've essentially added a 0 to the 3. 3 times 100 is 300. We've taken the 2 zeros from 100 and we've essentially added it to the 3. If I did 3 times 1,000,000, well, that's going to be 3,000,000, right? We've taken our 6 zeros in this case and added them to the 3. So we see that this is a pretty straightforward process. Another way we can think of this, though, is 3 is basically 3 with a decimal, and then we can put as many zeros as we want after it, right? And we used this technique in the last video for converting fractions into decimals because we needed this for the long division. But notice what happens when we multiply by 10. Multiplying by 10 essentially means we're taking our decimal and we're moving it over by one place, and we're getting 30, and then we still have all these zeros, right? So we can actually think about multiplying by 10 as moving our decimal over by 1. Or what about 100? So I'll put a few decimals after our 3 here. 100 has 2 zeros, so if we imagine taking our decimal and moving it over 2 places, we end up getting 300, right? The decimal moves over, we add 2 extra zeros to the number before the decimal, we get 300. 3 times 1,000,000, right? So I'm going to put a bunch of zeros after my 3 here. 1,000,000's got 6 zeros, so we're going to imagine taking our decimal and sliding it over 6 places. And what that does is it moves the decimal over, freeing up 6 zeros here, so our 3 becomes a 3,000,000. So we see that this is kind of another way we can think of multiplying by these powers of 10. So the next thing I want to do is look at what does it mean to divide by powers of 10. So in the exercise video of the last video, we looked at dividing by 10 and we saw that there was a pattern to it. So we saw that 3 divided by 10, which was the same as 3/10, right? 3 divided by 10 was 0.3. 5 divided by 10, right, or 5/10 was the same as 0.5. 9 divided by 10, or 9/10, was 0.9. So we saw that there was a pattern to it where we essentially put the number after the decimal. But if we think about it like what we did up here with the multiplication, if we consider 3.0, if I take this decimal and I slide it over 1, so instead of going to the right like we did with multiplication, we're sliding it to the left because it's division now, and division is the opposite. What we're going to end up with is 0.3. Oh, so this actually works out quite nicely, right? Start with 5, we slide the decimal over 1, so now we're going to be left with 0.5, right? Start with 9, slide the decimal over 1, now we're at 0.9. So we see that with this decimal sliding, we get a really nice way of thinking about powers of 10. We're multiplying by a power of 10, we'll slide the decimal to the right by however many zeros there are, and dividing by a power of 10, we'll slide the decimal to the left. So let's see if it also works with hundreds and thousands and 10,000s and so on. And indeed it does. So if, for example, we tried something like 17 out of 100, we could do long division just to confirm this for one of them. So how many times does 100 go into 17? It doesn't, right? So we have to put a 0 here, put a decimal, and we're going to add a 0.0. How many times does 100 go into 170? Well, it can only fit in there once before we get too big. So 1 times 100 is 100. Subtract that off, we're left with 70. But 100 can't go into 70, so we have to add another extra 0 here, bring it down, and we see how many times can 100 go into 700. Goes in exactly 7 times, right? 700 minus 700 is 0. So we get that 17 over 100, which is the same as 17 divided by 100, is just 0.17. So we can think about this as we've essentially taken 17, and we've taken this 0 and we slid it over not 1 but 2 places this time because of the 2 zeros from the 100. So this pattern is going to hold with every number. If I tried something like 3 out of 1,000, what we have to do is we take a 3, and we can also pad the front with zeros. That's not really changing the fact that it's a 3, but it's going to be helpful because we're going to be moving this decimal to the left multiple times because of these multiple zeros here. So we're going to move it over 3 times because 1,000 has 3 zeros. 1, 2, 3 places. So what we're going to be left with then is 0 point, and then there's 2 zeros here, 0, 0, 3. So 3 over 1,000 is 0.003. So instead of having to do the long division every time, we're able to just convert it by moving the decimal over. So that is how you multiply and divide by powers of 10. So why is this going to be useful for us with converting decimals to fractions? Let's find out. Whoosh. All right, so let's say I take a decimal here, 0.24. All right, and I want to convert that into a fraction. Well, how can I do that? Well, if we just think about how we could get this 0.24, we can imagine taking a 24 with its decimal point right here and moving it over 2 places. But what would accomplish moving the decimal to the left by 2? Dividing by 100, right? So we get 24 over 100 would give us 0.24 using the rule that we just used, right? So this is a pretty nice and quick way, we're pretty much already done, to convert the decimal into the fraction. However, this is a fraction that can be simplified. You might notice that the numerator and denominator aren't co-prime with each other. They have some common factors, so we can simplify it. These are both divisible by 4. So if we divide the numerator and denominator by 4 each, we get 6 over 25. So we see that 6 over 25 actually ends up being the most simplified fraction that we converted 0.24 into. So let's try another one. How about 0.71? All right, so again, it's 2 decimal places. So we're thinking about taking this number 71 and we're putting it over top of 100 because we've moved the decimal over 2 spots, right? 71 with the decimal after 1, we slide it to the left by 2 places. That's what dividing by 100 ultimately accomplishes, and that'll give us 0.71. So we've worked backwards in this way. And 71 over 100 is already simplified. You can check. 71, I'm pretty sure, is a prime number. Yeah, 71 is a prime number, so this will be already simplified. And let's do another example here, just with maybe a longer decimal. So we got 0.00055. So the number on top is just going to be this 55 here. But how many decimals was it moved over? Well, ultimately the decimal started after the second 5 here, and it was shifted over to here. So how many times was the decimal moved over by? It was moved over 1, 2, 3, 4, 5 times. So that means we're going to need to have 55 and divide it by a number with 5 zeros. So we have 55 out of 100,000 as the fraction that gives us this decimal. Right? We're just exploiting this kind of property of dividing by powers of 10. But now we can convert this into a more simplified fraction, right? Yes, this is a fraction that gives us this, but it's not necessarily the best fraction that gives us it. So 55 and 100,000, their greatest common factor is going to be 5. That's because 55, that equals 5 times 11. And 11 is not a factor of 100,000, but 5 is a factor of 100,000. So since 5 is a factor of both 55 and 100,000, but the other factor of 55 is not, that means their greatest common factor is just going to be 5. So we'll divide both the numerator and the denominator by 5. 55 divided by 5 is 11. 100,000 divided by 5, that should be 20,000. Right? 20 goes into 100 5 times, so 20,000 should go into 100,000 5 times. So the simplified fraction for this is 11 out of 20,000. So that's pretty much it for converting decimals to fractions. All we had to do was take the decimal, write the number on top as though there were no decimal, right? And figure out how many times the decimal after the number was shifted over by, right? In this case, it was moved over 5 times. So that's going to be equivalent to the power of 10 that we divide by, right? The amount of zeros in that power of 10, as we saw in the properties of dividing by power of 10 earlier in the video. And then once we get that fraction, we're going to simplify the fraction, and then that is going to be the most simplified fraction that is equal to our decimal. So let's just do one more example for the road. 0.202. So we'll take the number without the decimal, that's 202. And how many decimals was moved over? 1, 2, 3. So we will add in a power of 10 with 3 zeros, so that's 1,000. So 202 divided by 1,000, or 202 over 1,000, gives us the 0.202. Can we simplify? Yes, we can. They can both be divided by 2. So we get 101 over 500. And this is the simplified fraction. So this is the best way to write 0.202. So now we know how to convert between decimals and fractions back and forth. We can meander between these two lands of decimals and fractions freely, right? We can start with a fraction, convert it to a decimal, or we can start with a decimal and convert it back into a fraction. We have complete control now over these two types of numbers, these two ways of expressing the same number. And yeah, it's a pretty cool feeling. And before we go, I have one quick thing to show you. So this is a bit of a calculator application. So a lot of scientific calculators will have a button that will allow you to convert between fractions and decimals. So one such calculator is the Casio calculator. And you see this little button here that says S to D. So there's like an S and then there's like a little arrow between them and D. So that means it's converting between S, or the standard form, which is going to be fractions, and D, which is going to be decimals. So if I do 6 divided by 8, that gives me 0.75, so that's the decimal. But if I press this button, see, it converts it into a fraction, 3 over 4. This little kind of right angle symbol there in the middle is just this calculator's way of expressing division. But we see that 6/8, yeah, that is 3 over 4, right? That's the most simplified version of the fraction if we divide both the numerator and the denominator by 2. So, and then if we press it again, it takes us back to 0.75, right? So we can freely convert between fractions and decimals on this calculator with this S to D button. Some calculators may say F to D on it for fractions to decimals. And there's another calculator that I also have that I can show you how to do this for. All right, so this is my fancy boy calculator, and it has a lot more capabilities than the other one, but it does still have the fraction to decimal conversion. So let's say I do 6 over 8, so that's telling me it's 0.75. If I want to convert that into fraction, I press math, then we have a bunch of options, but it's the first one there, frac, right? So that 2 frac means it's going to convert it to a fraction, so I just press 1. So it's going to take my answer, the 0.75, and convert it into a fraction. See, and it gives me 3/4, just like the other calculator did. And if I want to convert that back into a decimal, I'll press math, and then you see the second one there, it says 2 dec, or 2 decimal. So if I press 2, right, because there's a 2 beside it, that'll make it go to the decimal. So then I press enter, and it puts it back to 0.75. So that's just a couple calculators with a couple different examples of how to do it. Check to see if your scientific calculator has this option, and if it does, that'll help you a lot when you're doing some practice. If not, no worries, you can always just look up online, what's this fraction as a decimal, or what's this decimal as a fraction, and you should be able to find something. Alright, well, that's going to do it for me today. I hope you found this video useful. You now can convert freely between decimals and fractions. using 2 different methods, and you also know how to do this with your calculator. So that's going to do it for me today. You have a good one, stay groovy, and I'll see you in that next video.
F.O.A. Maths.